So for Module 3, we're going to be focusing on analog signals. Okay? And to begin that, we're going to be comparing, what is the difference between a digital signal, as we talked in Module 2, and an analog signal. So as remember, digital kind of looked like this square wave. It would either be low or high. So then it looked very boxy, either being low or high. There's only one or the other. Alright, so then let's go ahead and compare this to what analog is. So analog is something a little new. And the biggest difference is that it's going to be a continuous wave between 5 volts ground, so 0 volts, and then all the way back down to a negative 5 volts. So it's going to alternate across this. And it looks something like this. So I'm going to draw a wave here. And I'm trying my best to make this look like a wave. So for comparison, let's go ahead and with this blue line I'm drawing right here, this is what a digital signal would look like. So it's coming in and it goes up to 5 volts and it's going to come back down. Whereas analog, kind of tracing it with this green pin, I'm going to kind of go around, I'm getting curves, and this gives us, an infinite amount of values between 5 and 0 volts. Okay, so then what is analog useful for? So it's useful for reading sensors. But what's the difference between reading a temperature sensor, for example, with digital and analog? And, before we talk too much, know that there are ways to get really good readings with digital, but it's just a little more complex. So let's just compare straight digital and then straight analog. So for a temperature, let's say digital, we could be hot or cold. And we really just get that one or the other kind of thing. So we could say, if it's above 70 degrees, be hot, or if it's below 70 degrees, be cold. Whereas analog, we get kind of more of a natural way of telling temperature. We get a lot of points to refer to. And we're going to refer to that as like high points of resolution. And so here you kind of see a little thermometer. I could read 20, 30, 40, 50, 60, 20.5 degrees. I just get a lot of degrees of freedom. And this is something we're going to use to our advantage in some sensors later in this module.